night rest. All right, this morning we're going to examine a question in physics, and this is a Y question, 1994 question. All right, let's look at the problem. In 24 days, a radioactive isotope decreases in mass from 64 grams to 2 grams. What is the half-life of the radioactive material? All right, one thing that interests me in this question is the fact that we want to look at the application of the Zhepwo method to solving this problem. When you are given a problem in radioactivity, because this question is under radioactivity, let's not forget that radioactivity is the spontaneous, disintegration of an atomic nuclei, which will be accompanied by emission of either alpha particle, beta particle, or gamma ray, or a combination of the three emissions, radioactive emissions. All right, so there are basically two methods, of solving problems, mathematical problems relating to radioactivity. It's either you use the conventional method or you use the Zhepwo method. Not many persons are familiar with the Zhepwo method, but almost every student of senior secondary schools are familiar with the conventional method. And that's why I decided to use the Zhepwo method in order to make us realize that the conventional method is not the only method that can be used to solve problems relating to radioactivity. All right, so I'm going to introduce us based on what we have in the question. We have to calculate the half-life. The Zhepwo formulae, there are so many of them, but we're going to use only one following the question that we are given. In my other videos, I will introduce us to other formulas under the Zhepwo method. All right, first thing first, let us find the solution to the problem by listing out the parameters that we are given in the question. In 24 days, a radioactive isotope decreases in mass. The 24 days here represent the time taken for the radioactive isotope to decay. All right, so we use small t for that. That's the time taken for the radioactive isotope to decay. So our time taken is 24 days. All right, so 24 days to decrease in mass from 64 to 2 grams. That means the initial mass of the isotope, was 64. So we're going to use N1 to represent that. N1 equals 64 grams. N1 here represents the initial mass, of the radioactive isotope. So to decrease in mass from 64 to 2 grams. So 2 grams will represent the final mass of the radioactive isotope. All right, so we use N2 to represent the final mass. So what is the half-life of the radioactive isotope material? Half-life here, let us use capital T to represent half-life, And based on the Zhepwo formula, to calculate half-life, we use small t divided by the logarithm of r base 2. All right, so we know what our small t is, which is 24 days. The r here represents disintegrating ratio. We call it disintegrating ratio. And it is given by N1 divided by N2. So we have our N1, which is 64 grams, and then we have our N2, which is 2 grams. So when you divide 64 by 2, you have 32. Of course, gram and gram will go off. So it means that your R is 32. That means the disintegrating ratio is 32. Don't forget, we are using the Zhepwo method instead of the conventional method. All right, so when you substitute these parameters into the equation, you will have 24, that is 24 days, divided by the logarithm of 32 base 2. All right, from here, you know that this will be 24 divided by, we can express this 32, this argument 32, in index form. That will be 2 to the power of 5 base 2. And of course, from your knowledge of logarithm, your t, the half-life, will become 24. You can bring this 5 here so that you have 5 log 2 base 2. You know that this log 2 base 2 is 1. Okay, so it means that this half-life is 24 divided by 5. That is 24 days divided by 5. And when you divide 24 by 5, we're going to have 4.8 days. So 4.8 days is the half-life of this radioactive isotope. And I believe you will know what half-life means. That is the time taken for a radioactive isotope to disintegrate to half of its initial mass, okay, to decay to half of its initial mass, meaning that if an isotope is let's say 50 grams, for example, I'm just trying to explain half-life, the time taken for it to decay to 25 grams is what we call half-life. So for this question, the half-life of the radioactive material is 4.8 days. So you can confirm this result using your conventional method, which you are all familiar with. All right, so in my next video, I'm going to introduce us, pick another question under radioactivity, try to use another Zhepwo formula so that we can all be familiar with this rather than just knowing the conventional method. All right, so this is all I have for us today. Feel free to pass your comments in the comment section below. We'll promise to give you the best and the best always. All right, thank you.